Section 3.3 lecture. In this section, we want to talk about measure of relative standing and box plot. And first, we want to talk about Z. What is the Z score? On the previous sections, I explained about this example. This is an example that is kind of exaggerated, but just to understand the critical zone when you are drawing a bell-shaped curve or a bar graph. A couple want to have 20 children. And what's the probability of have no girls? All 20 are boys is 0. What's the probability of 1 out of 20 is girl is 0? So you see the probability increase. Like what's the probability of 7 out of 20 is girls? So the probability keep increasing till to reach to 10. What's the probability that half of 20 are girls? So in that case, you reach to the peak and then drop. So here, like, what's the probability of 16 out of 20 are girls? Then the probability keep dropping again. So there are 2 points, 2 border points. Then when you go beyond it or you go below that, then it's very, very unusual. Like it's very unusual to have 4 and less or 15 or more girls. Now, so these are Z. These 2 points are the value of Z. They call it critical zone. And you see in this picture, these are the critical area. So if you go beyond or below this, you fall into the critical. So if your number fall on these 2 areas, it's unusual value. Now, the Z is mean plus 2 standard deviation. Mean plus 2 standard deviation. So these 2 points, it's mean plus 2 standard deviation and mean minus 2 standard deviation. If you assume that mean is 0 and standard deviation is 1, then mean plus 2s is 0 plus 2 times 1 or 2, and mean minus 2x is 0 minus 2 times 1 or negative 2. So these 2 points, 2 and negative 2, are your Z value, and you don't want to go beyond this or below this. In that case, it's unusual or unusual. But if your number falls between these 2, you know, this is 0, 1, negative 1. So if your number falls between these 2, then it's usual, it's not unusual. So that's where Z value stands for. So you see on this picture, if Z is between 2 and negative 2, value is not significant, but if it's beyond, it's significantly high, and if it's below, it's significantly low. Now, where do we use Z? If there are, if you are comparing 2 things or 2 items, then since they are not compatible, you have to use Z in order to bring both to the one unit. For instance, in this example they have here, they want to measure the body data, and here the mean and the standard deviations are given, and the value of X is 75. So this is how to calculate the mean. Now, So here, Z, the number of standard deviation that given value of X is above or below the mean. There are, both formula are the same thing. It depends. In the problems, if you are talking about the populations, then you're using, for the mean, you're using this symbol. If you are talking about the sample, you're using this symbol. So either formula is the same thing. So when you have a problems, is either population or sample, but as far as calculating Z, make no difference. And you want to round it to 2 decimal places. So this is again talking about the Z always has to be between 2 and -2. Unusual is if it's greater than 2 or less than 2. And then another subject, you call it percentile. Percentile is been used. You hear it sometimes that you're asking the instructor to curve the test and curve the score, stuff like that. That's where we use the percentile. Percentile is if you take a piece of line, let's say you take a piece of line and divide it into 100 sections, and they are all equal pieces, then it's 1%, 2%, 3%, all the way to 100%. That's what the percentile is. For instance, let's say you find the first one is Q1 is 25% of the data fall here. Then Q2 is 50% of data fall here. And then you have 75% of, they call it Q3. So that's how you divide the entire straight line into 4 equal pieces. All right. And there are 2 formulas. So to understand the percentile better, we'd rather to go to the example and show you how it works. All right. So to calculate the percentile, the formula is you have to take number of value less than X, divide by total number of value, and then multiply by 100, and vice versa if you want to find the value of the percentile. For example, these numbers are given in the problems. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 24 numbers here. They want to take all these numbers and drop it on the percentiles. Means here they want to take all these numbers and start just say, okay, 110 is here, 120 is here, 178, and so on. But they want to know what is the percent of the whole thing for each number. So in that case, we are using this formula. Okay, first, they ask us to find the percentile corresponding to 213. So to do that, to find the percentile of 213, we need to know how many numbers are before 213. See, 213 is right here. How many numbers are before 213? 1, 2, 3. So you put that 3 here. How many numbers do we have all together? What's the total number of value? There are 24 numbers. So you put that one here and multiply by 100. So the percentile of 213 is 13%. Means when you list all the numbers on the number line, 213 is 13% of the whole line. What about 240? 240, how many numbers are before 240? 1, 2, 3, 4, 5, 6, 7, 8. So it would be 8 divided by 24. So 240 is 33rd percentile. How about 250? Remember, there is 250. Always take the first one. So how many numbers are before this? You count that, would be 12, and so on. This is how to calculate the percentiles. So to calculate the percentile, this is a formula. Now, The next is you have the vice versa. You have the percentile. Now you want to find the actual value. So in that case, in this example, I want to see what number is in percentile of 60. Means when you have all these lines, when you have 60 percentile, what number is there? What number is located at 60 percentile? That's what you're asking here. So for that, we are using this formula. In this formula, K is the percentile given in the problems. L is position of that value. And then N, of course, is total number. So here, percentile is 75. This is 75 divided by 100. K is 75. And then how many numbers we have? 24. So that is 18. Now, if the value is whole number, don't take that number. You got to take the average of that number and the next, L and L plus 1. If L is the decimal, then you round it up. It means is this, is 18. When it's whole number, don't start counting and stop at 18. No. You have to take 18 and 19 and then the average of those two. It happened that both in this case are the same thing, same number. So that would be 255. Same thing here. You have a whole number. Don't start counting and say, well, number 12 is this. No, number 12 is not 245. You have, when you have a whole number, you got to take an average of what number is a position 12 and what number is a position 13, and then take the average. So what is the percentile of 50 is 247.5, and so on. But if it's a decimal, you get it rounded up. Like in this one, if the outcome is the decimal number, then you always round it up. So then you say 15. Then you start counting and see which number is in position 15. Okay? And then you take that one and put it here, which is 251. See, you start counting here 1, 2, 3, 4, 5, 12, 13, 14, 15. That's how you find your number. So remember, if it's a decimal number, you get it rounded up. If it's a whole number, you have to take the average of that number and the next. This is just in case you want to find the value. So there are two different formulas that we are using here. And for that, I have more examples here for you. Q3 means 75%. Q25 or Q1 is 25%. And 50 means Q2. So you see, because you come up with a whole number, you take the average. Next is the construction of box plot, as you see on this picture. Box plot is another way of presenting your data. To have the box plot, first we look at the definition here. A box plot is a graph of data that consists of the line extending from minimum to the maximum. So there are 5 numbers that we are using for box plot. Those 5 numbers are minimum, maximum, Q1, Q2, Q3. when you graph the box plot, like these are two examples. If the box plot looks like this, that means you have a bell shape. If the box or this rectangle is on the left side, then you know your graph is go to the left here. Let's go to the right. I'm sorry, let's go to the right. So that is like this. And these are better picture here, see? So these are the 5 numbers, are minimum, maximum, Q1, Q2, Q3. This is a situation that you have a bell shape because it's almost in the center. So we are using Q1, Q2, Q3. This is another example that shows how we graph it. You have them. So you need 5 numbers for box plot: minimum, maximum, Q1, Q2, Q2 also is the median. So if you calculate the median, that would be your Q2. Like in this example, these numbers are given. They ask us to construct a box plot. So in that case, I need to find minimum, maximum, Q1, Q2, Q3. So Q1 is 25% of the total. It's 4.5. Remember, if it's decimal number, you round it up to the 5. So position of 5, 1, 2, 3, 4, 5. So that would be 14. Median is 50% of n, means 50 times 8, there are 18 numbers, divided by 1, 9. If there is a whole number, you always take average of 9 and 10. 9 and 10 both happen to be 18, so Q2 is 18. 75% is 13.5. So if it's a decimal, you always round it up to 14. 14 happen to be here. When you start counting, number 14 is here. So now you have your Q1, Q2, Q3. Now here is if you want to graph it using the calculator, I'll show you on the homework later on. That's how plug it into the calculator to find those numbers. These are other example that for the box plot, the solution for these is on this page. Then we have outlier and modified box plot. Now, I want to construct a modified box plot and find the outliers. These numbers are given, and first you want to draw the box plot. So you find your smallest one, largest one, Q1, Q2, Q3. Now, these are the formula we use for modified box plot. First, you get to take result of Q3 minus Q1. You subtract these two is 11. The next formula is you take that IQR, whatever it is, and multiply by 1.5. This is a constant number, 1.5. That is 16.5. When you find your IQR, since you have your Q1 and Q3, you plug it into this formula. What you have here is the range. Means if your number fall between these two, you're okay. If your number fall greater or less than this, that number is the outlier. So here we had all these numbers. First of all, it's obvious that this number is outlier because it's not even close to any of these. But if you want to show it using the box plot, they call it modified box plot, you got to go through this calculation, find the range first. When you find the range, if your number is outside of the range, then you say this is the outlier. So this is outlier and modified box plot. Here is definition of the outlier. Is a value that lies very far away from the vast majority of other values. These are Q1, Q2, Q3. So you have 5 numbers to graph a box plot: minimum, maximum, Q1, Q2, Q3. Q2 happen to be it. Here is about modified box plot. You can read that one. How to construct it, we explained that. So the rest is just some information for the box plot, okay? So next, on my next lecture, I go through, so like in this example, These two numbers fall out of the range. So that means these are, when you draft the box plot, this is a modified box plot because it shows that these two numbers are not within the range. So they're outliers.